It is interesting that traditional connected data graph approaches rely on indexes. They're very important. They are the entry point into a graph domain or a universe of data. And if you have these initial anchor or entry points into your graph, and then you leverage the index-free adjacency or these direct pointers to other data, you can be fairly performant and assert that you are looking at the appropriate data. It's kind of like, not to get all mathematical, but it's kind of like the challenge though in ordinary differential equations and you're trying to do simulation. You have to believe strongly in your assertions on your initial beliefs. And that's the problem with traditional graph approaches, or the challenge, not the problem. And that is, you have to have a strong belief in the starting points that you choose in your graph. And if your graph is small enough, there's some flexibility there. If you're talking large amounts of data that we would see in cybercrime, that we see in sensor data, or as our world is becoming more connected, so is our data, and that means that it's becoming, just a massive amount of information. Being able to properly choose those starting points is getting very challenging, and you're leaving potentially a lot of information on the table in your analysis. But I'm curious, David Haglin, so would you agree with that concept for graph-wide scanning, and what do you think about that?
So one of the values or the benefits of using a graph is being able to blend data from multiple sources into the same resource that you can query. Mm-hmm. So as you think about adding more data, which is really helpful to getting the right kind of answers that you want, the data is growing that much faster. And a lot of people think, well, with the graph this size, the only thing we can possibly do is just take a random sample, and look for the. Oh my gosh, in cybersecurity, that is the worst thing, because you're leaving everything on the table outside of the scope of what you're looking at. Another possibility is that you start from a certain seed set or anchor, and again, maybe do a fairly complex search around that initial seed set, but you're looking at 1% of the graph. To see the big picture, you have to scan the entire graph. You have to look for the pattern everywhere. And the really valuable answers, especially in cybersecurity, are these, you have to do the whole graph. So I actually categorize the seed set or anchored thing. I call that graph lookup. And how you get to the anchor fast is important for performance, that kind of querying. If you need to scan the whole graph, the index to find a particular anchor doesn't help at all. So I think of that as actually a different kind of graph search problem. It's fundamentally different in how you optimize for it and how you get performance that's needed.